Hi everybody, welcome to our lesson 6.2. We are going to have a look at systems now of linear inequalities. So two lines or two linear inequalities on the same graph. That's what we're looking at when we talk about systems. So what is a system? In Math 10, when we dealt with linear equations, so for example, in red here I have y equals negative x plus 2, and another equation, y equals 3x minus 2 in blue, I could have graphed those two lines, and if I graph them on the same grid, that's what we call a system. So each one of those equations could be representing some possible scenario, and I'm looking for a solution to that system. Okay. When we graph two lines or two equations on the same Cartesian grid, we say that the point where they intersect is called the solution to the system. So in other words, when I have two graphs or two lines, okay, on the same grid, there's only going to be one possible point here where the values of x and y satisfy both that equation and this equation. Okay, as I can see here, because they only cross in one place, that tells me that there's only one point there. And if I look at what's the value of that point, what are the coordinates of this point? It is equal to 1 for x. Okay, I see that it's at 1 for x, and it's also at 1 for y. So this point where they cross, point of intersection, is the point 1, 1. So the solution is 1, 1. What that means to us is that when x is equal to 1 and y is equal to 1, that point satisfies the red equation as well as the blue equation. And there's no other place on this graph where these lines cross, which tells me that there's no other possible solution for this system. Okay, so really simply then, when you're asked to solve something, it just means find the point where those two lines cross, find the point of intersection. That's what we did in Math 10. In Math 11, oops, sorry. Okay, in Math 11, we're going to deal with linear inequalities instead of linear equations. So the difference for us is that we're simply going to be looking at graphs where we have two lines that may intersect, but also we have two shaded regions which might overlap as well. Okay, so our solution could be more than just one point. It could be an entire region where the two shaded regions overlap. So coming back for a moment though, when you find the point of intersection for a system of linear equations, you've found the solution. Okay, so when you find where things overlap or intersect, that is the solution. Let's do an example here. Okay, if I was told that the system of linear inequalities, y equals negative x plus 2, and y is equal to 3x minus 2, is found to have the solution 1, 1. Okay, without graphing it, how could I check that that solution is correct? Okay, so if I'm given a question where I'm provided with a solution, I could check and make sure that it satisfies both equations in the same way that I check a test point and I plug that test point into an equation. Okay, to verify a solution, verify means to check it. And by checking it, we can substitute the x and the y values from our point into each of those two equations and make sure that, yes, they do satisfy both equations. So in this case, our solution, if it's given to us as 1, 1, we're going to check it. Okay, so we're going to verify the point 1, 1. Remember that x comes before y when you're looking at the coordinates of a point. So this solution is when x equals 1 and y equals 1. I want to just plug those two values, x equals 1 and y equals 1, into both of my linear equations. Okay, so I'm going to substitute this point. So to verify, I will substitute okay, x equals 1 and y is going to equal 1 as well into both linear equations. So I'll be doing this twice. So really there's two checks that I have to do. Okay, let's do equation 1 over here. So equation 1 is going to be the red one. So here's equation 1. Y is equal to negative x plus 2. Okay, and equation 2, give myself some room over here, is this equation. Y is equal to 3x minus 2. Okay, and so if, sorry, that's an x. Okay, if I'm going to go ahead and check now, what I'm going to do is everywhere that I see a y here, I'm going to put a 1 instead, and everywhere I see an x, I'm going to substitute in a 1 as well. So it's going to be 1, okay, equals, I've got that negative sign in front of the x. It needs to stay there. I'm simply just substituting in a 1 for the x, plus 2. Okay, so 1 is equal to negative 1 plus 2. Well, let's put those numbers together on the right-hand side. 1 is equal to negative 1 plus 2, same as 2 minus 1, is 1. So this statement is true. Okay, the left side equals the right side. It's a true statement. So far the solution 1,1 has been verified for my first equation, y equals negative x plus 2. Let's come over to the blue one and we're going to do the same thing. Okay, this time I'm going to put in a 1 for that y. I'm also going to put in a 1 for the x, so it's going to be 3 times 1 instead of 3 times x. Okay, minus 2. So again, I can do the math. Well, 3 times 1 is 3. 3 minus 2 is 1. So this is also true. Another way to say that is this is valid. This is called a valid solution. Okay, so because the 0.11 is a valid solution for both of my linear equations, I would say yes, I have verified it, and yes, the 0.11. Okay, 1,1 is a solution. Okay. Systems of linear inequalities are a lot like systems of equations. Okay, the only difference, again, is that we don't have an equal sign. Okay, in our equation we have an inequality sign, and we have to deal with that inequality sign. Okay, that inequality sign tells us to do certain things. So for example, it tells us to shade a side or use a dashed line or use a solid line or stipple. And so we have to graph it just like we would any other linear inequality. And then we're going to be looking for points of intersection as well as overlapping of the solution regions. So here in our notes it says, just as two linear equations form a system, two linear inequalities also form a system. Okay, so for example, instead of y equals negative x plus 2, I could have y is greater than or equal to negative x plus 2. And there's one linear inequality. And on the same graph, I could also graph, let's say y is greater than or equal to 3x minus 2. So because I have two different linear inequalities, I know that's a system. It's not just a graph of one linear inequality. And what I would be looking for is this. Okay, the solution set. So instead of calling it a solution now, we call it a solution set because it could be a larger area. It's going to be possibly the intersection, okay, the point of intersection, and the overlapping of those solution regions. So it might be where the two boundary lines cross, that's a possibility, but it's definitely going to be where those two solution regions overlap. If I were to graph this and I see that the solution regions do not overlap, okay, then there is no solution. I'm going to stop this lesson right here, and I'm going to ask you to, in your notes, you're going to skip the examples that follow in your notes right now. We're going to carry on at 6.3, and we're going to do some of these graphs right now, and we're going to find the solution to systems of linear inequalities. So join me in just a moment with 6.3 in a different video. Thank you.